Students, we can go to next session, that is atomic radii and electronegativity. I will discuss first electronegativity. Electronegativity means, suppose you have two atoms A and B, they are covalently bonded. Therefore, the shared pair of electron will be at the middle of between two nucleus of A and B, at the middle of between two nucleus. But after the bond formation, you know what happens? This AB A will be here, B will be here. After the bond formation, just like after the marriage, husband taking all the belongings of wife towards her, just like, for example, after the bond formation, this shared pair is attracted towards B. Okay, suppose this is the electron of B, this is electron of A. Now B has got in some extra nuclear charge that is reflected by a negative charge here. The electron lost is reflected by a partial positive charge. This tendency of B is called the electronegativity of B. Okay? It is the tendency of an atom to attract shared pair of electrons towards it. Remember, my students, if there is a bond between two different atoms, there will be this tendency. One of the two atoms will attract shared pair towards it. If there is no electronegativity, means the bond will be between same atoms. There is no electronegativity because both have same tendency. But if there is no electronegativity, but you have a bond like this, there will be an electronegativity. Okay? But the electronegativity, suppose you have a bond like sodium and hydrogen, now the hydrogen will be negative, sodium will be positive. Therefore, which element has the partial negative charge depends upon their value of electronegativity. Electronegativity has been calculated by Millikan scale, Alfred-Roca scale. These are the two important. In the Millikan scale, electronegativity is equal to ionization energy plus electron gain enthalpy divided by 2. Okay. It is a sum of ionization energy plus electron gain enthalpy divided by 2. Now, I have listed electronegativity of certain elements here. You please note, first period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. 1, 1.5, 2, 2.5, 3, 3.5, 4. Here a hydrogen is almost 1.9. Therefore, electronegativity increases along the period. Down the group, electronegativity decreases. For example, chlorine, bromine, iodine, astatine. Oxygen, sulfur, selenium decreased. You should have an idea about these values. 4, 3, 2.8, 2.5, 2.2. Have you noticed that this difference not reflected here? This difference not reflected here. There is a specific reason we would discuss in another chapter. Okay, here also that is noticed. Please note here, carbon 2.5, all others are 1.8. Notice that. Boron 2, aluminum 1.5, but again increase, just increase. This is discussed in P block elements, you know. Reason is discussed in P block element, group 13. Please note this. Okay, here also, therefore down the group, generally electronegativity decrease, but that is not a regular trend. In the second and third period, there is considerable decrease. But rest of the periods, there is a decrease, but not the higher magnitude as here. Okay? Yes, this is particularly noted. Boron thallium will decrease, then increase. Noted. This is the most electronegative element. Most electronegative. Number 1. This is number 2. Number 3, nitrogen and chlorine. But normally people say that number 3 for nitrogen, number 4 for chlorine. Okay. This is a rough value. Please remember. Rough value. We have adjusted value. Don't think that I have already said you there is 2 elements having same value of electronegativity. Yes, if nitrogen and chlorine NCl3, which has a partial negative charge, nitrogen has a partial negative charge. Okay, yes, this is a brief of electronegativity. Most electronegative atom is fluorine. Now we can go to next, atomic radii. What is a short trick for atomic radii? We know that atomic radius is the distance from nucleus to the valence shell. This is N or valence shell. Agree? Radius depends upon size, nuclear charge, number of shells. In the chapter atomic structure, you know the radius is equal to 0.59 angstrom, 0.53 angstrom, n square by z. What is z? Number of valence shell. What is z? Nuclear charge. Therefore, when number of shell increases, radius increases. When nuclear charge increases, radius decreases. Now, what is a trick for radius? What is a technique for doing radius? We know that. I'll give you a technique. Radius, that is ionic radius, or radius, directly proportional to negative charge, inversely proportional to positive charge. When negative charge increases, radius will increase. When positive charge will increase, radius will decrease. Suppose a question. Select correct order of radii. Radii means plural of radius. That is, you have N3 minus, O2 minus, Na plus, F minus, neon. You have three type of species: positive, negative, neutral. Therefore, this is our technique. Negative more radius than, neutral more radius than positive. This is a technique. Negative more radius than, neutral more radius than positive. When negative charge increases, radius will again increase. When positive charge increases, radius will decrease. Therefore, the correct order, Na plus, then neon, then F minus, then O2 minus, then N3 minus. Okay. Suppose another question. Aluminum 3 plus, sodium plus, magnesium plus, neon, N3 minus, oxygen 2 minus, F minus. What shall be the lowest radius for this? Aluminum 3 plus,
This is magnesium 2 plus, then magnesium 2 plus, then Na plus. Because all are positive charge, then move from here to here, positive charge decreases, then neutral, then F minus, O2 minus, N3 minus. Very simple, very simple. This is the trick. Negative greater than, neutral greater than, positive. You know why? When negative charge increases, the control of nucleus over the electron decreases, therefore it expands. When positive charge increases, nuclear charge is increasing, therefore control of the electron cloud increases, therefore it attracts towards it, therefore size decreases. Okay, thank you for watching.